Welcome to today's webinar. The title is Role of Rupture Discs in Process Optimization. So today we will look at bursting discs and also known as rupture discs, and how they implement in your processes today, and also the challenges you may feel, also the way they work, and also how you can make it more efficient, pick the right design. There are so many designs to pick from, and how do you know to pick the right one? So we will help up with this today. Hopefully Melky understand a little bit more. Today I'm joined by a spokesperson from CDC. His name is Philip. Philip has been working in the rupture disc industry for the past 15 years. He's working at CDC, and he has a big value in creating new product matter development, and that's something that CDC is very strong with today. That's why we at Thurne Technique are working together with CDC, because they are so good when it comes to their development and their processes, and also their case-by-case studies, that they really provide the best technology out there on the market. Now, depending on where you're located, these are your different product sales managers, depending on where you're located. So for example, in Finland, we have Olli-Pekka. So he's responsible for the Finnish market. And then we have me, Alfred Berglund, again, for Sweden, Denmark, and Finland. Sweden, Denmark, and Norway. We also have Andris. He's in the Baltics. So you contact him if you're located in Estonia, Latvia, or Lithuania. And if you're located in Poland, you will speak to Rota. We have social media platforms. We post there frequently. You can look at other webinars. You can look at some news articles. We're sharing news with suppliers, keeping engagement with our customers as well. So we have LinkedIn, we have Facebook, we have YouTube. I think that will conclude it, so we can present our spokesperson today, Philip.
So thank you again all for coming. I hope you have a nice day so far. So what we would like to cover today, as Alfred has introduced, is more of a look at the role of the rupture discs in process from a different standpoint, not from just a safety standpoint, but from what other impact the rupture discs have in the process, and what can we use them to deliver efficiency and optimization in the process. So hopefully it will cover a couple of things during today's session. Is one thing, if you're already facing some challenges, what can we possibly do and look from technology standpoint, or perhaps giving you an opportunity to look at the rupture discs role in a very different aspect. But let me start why, first of all, we are talking about this aspect beyond safety. Is we've all been facing, since beginning of pandemic, quite a lot of challenges. We are a manufacturing business as well, so we're facing the same challenges as our customers and our supply chain as well, and your customers as well. So, and in this particular market conditions right now, so some of our customers actually feeling big increase in business, like pharmaceutical industry, for example, and parts of chemical industry, food industry. Some businesses need to make themselves more efficient to ride this decline in some of the consumer, especially consumer side products. We're also since beginning of pandemic facing quite a lot of challenges with supply chain. So even moving goods from one place to another in pre-pandemic world was quite well-oiled machine of global trade, and now it's become more of a challenge. So even things like ports, seaports, their throughput has been reduced. So all of this have an impact on our productivity, and it does have put significant pressure on financial performance of all process segment customers. And that's what we would like to cover today, is how our product, which is, as I mentioned before, on primary function is to create a last line of defense from process. How can we actually use the technology to alleviate some of this pressure on our financial performance. And as any manufacturing business is, in order to face these challenges, we need to consistently and constantly improve in our operational efficiencies. So in a layman terms, in essence, we need to increase our productivity. And I'm saying we because, as I said, we're all facing the same challenges. But typically, when a business trying to increase its productivity, it comes at the cost. So you cannot have something for nothing. And and with increasing productivity, operational expenditure is increasing also. And I guess what we're trying to do in a sense is to look at how can we make this relationship in terms of use of rupture discs more on the positive side with a productivity outweighing operational expenditure. So in the sense of productivity, so we would typically look at three basic things. So it's to increase the uptime, so minimize any stoppages, so we can produce, given the same capacity, more of the product and deliver it to customers. Increase the throughput, so process intensification. That's also a fairly common technique to increase productivity and naturally reduce product waste. Now, all of this could be done in combination as well, so it's not an isolated thing. So when we look at more productivity, we look at this whole concept of making things more, using existing capacity, increasing our capacity, and reducing waste. Now, when we're trying to do this, typically, we are putting our manufacturing equipment at a significantly higher strain, and therefore it requires replacement, maintenance, and as such, again, it leads to possibility of wastage of, again, of product if we need to stop to carry out of maintenance, and also consumption of the spare parts for the equipment, and in terms of rupture discs as well. As you know, this is a replaceable item and constantly requires, as a part of maintenance, to replace them. So, and if we translate this philosophy into the rupture disc, what does productivity means in terms of rupture discs? So how can, what the rupture discs have an impact, how they have an impact on all what we're trying to do with increase of uptime, throughput, and reduction of waste. So naturally, reliability, it has direct correlation to productivity. The more reliable the process, the rupture disc can process, the more productive the process is. So, and things like, for example, process conditions, industrial controls, and rupture disc design itself has a direct correlation on productivity of the whole process. And naturally, the frequency of preventative maintenance, because at this point in time, we cannot positively or with any assurance say how long the rupture disc can survive in process. What we can do, and we're going to talk about this later on in the presentation, we can mitigate certain process conditions to make the longevity and reliability increase in terms of rupture disc and have a positive effect on the process. Now, in terms of operational expenditure, the rupture disc translates into the cost of ownership. So naturally, the consumption. So the more preventative maintenance we carry out to make process more reliable, the more rupture disc we consume. So that's a kind of a direct correlation on cost. Variety. So often this cost is exaggerated or exacerbated rather in terms of if on a single site, there is a number of different vendors, for example, or different designs by the same vendor are used in the process. Naturally, the procurement efficiencies are not there because economies of scale when it comes to rupture discs can only be achieved by standardizing as much as possible on the rupture disc designs and process. And in order to support all of this, stock needs to be carried out at any given time. So the more rupture disks being consumed, more frequently the stock sizes needs to be as large as to support it. So if we look at productivity and expenditure in itself and translate it into rupture disk, it translates into reliability versus cost of ownership. So that is a kind of a basic background when it comes of role of the rupture disk in process beyond its primary reason for safety. Now let's have a look on the next thing. So what are the challenges? How does it actually affect each other? So we already said now our primary goal in this particular exercise is to increase our production output. And whilst doing this, if we take it as well take into account the COVID situation and right now the pandemic, we have to do it with reduced personnel. Now, this directly have an effect of reliability of rupture disks. So intensification, as we discussed, has an impact on longevity of the rupture disk. When I'm talking about in general. Then if the rupture disks are becoming less reliable in the process because we're trying to intensify it, then they lead to premature failures. And that causes often, some of you may have experienced it, is unscheduled stops, which leads to all the things we're trying to actually avoid and improved on the other side. So it's uptime is affected, the productivity itself, the throughput, and that also leads to margin erosion. And in order to address that issue, again, we have to do more maintenance, we have to incur more cost in replacement, stock, and stock availability as well. If we're running out of the rupture disks, then we have to wait until the manufacturer will deliver a new set of spares. And this has a, again, direct impact on increasing cost and it limits uptime. So it's become sort of a vicious circle if we're doing it blindly without actually paying attention to technology. That's what we have. So it becomes like, as you all know, perhaps in a famous novel or movie there is, it's catch-22. So it's whilst we're trying to do one, it has an impact, significant impact on another aspect, and it's becoming like a vicious circle. And that's our main challenge that we see, and that's what our customers tell us. When we're trying to have a positive effect on one side, we're actually being prevented by the equipment that we use, and in this case of rupture disks. So this is just to create a background to show you that the rupture disks in general do have a significant impact on the process. They're not, they're there for safety, and that's what they provide, so safety is a given. But also, if you look at it, they can be, if they can have either positive or negative impact on the process. And that's what we are going to explore throughout this, this webinar. So what is it? What choices do we have in this particular situation? Well, the choices is do nothing. So let's just write it out. It's been working up till now. Okay, we'll just do nothing. It's a choice, a valid choice. Or we have a choice of just focus on driving the production output. So, and just hope that we're more efficient in doing that, that the cost we incur in order to facilitate. Okay, that's a choice as well. Focus on costs, that has been quite a prevalent thing in the past, well, since manufacturing process has been put in place. How can we maybe to, if we cannot, or our, perhaps the market conditions prevent us from selling our product, let's maybe just focus on the cost and produce whatever we produce at cheaper. It's also, in theory, would have a positive impact on our margins. Or we can use technology, and that's what we're here to discuss today. Is there a possibility then when we looked at the impact of the rupture disk in the process, is it something we can use to positively affect the both sides, allowing us to increase productivity, but actually also curtail the costs when it comes to the rupture disk use, and actually curtail the costs, more importantly, associated with stoppages, with both scheduled and unscheduled stoppages, and also more cost of maintenance. And also, let's not forget, the typical process plant is a very complex thing, and there is a lot of maintenance required on every piece of equipment. And what, I don't know if you are familiar with this and experiencing this yourselves, but we do hear quite a lot of feedback from our customers that it is now challenging to put maintenance crews on site because of limits on how many people you can have on site at any given time. So is there something we can do together in order to help ourselves and make us more efficient and facilitate all this focus on production output? And we believe there is, and that's why we're here. So HPX, this is based on HPX family of rupture disks. I'm not going to go through today through the technical aspect of it. We can, of course, speak about if you need on the separate sessions, but more in terms of how actually. I'm saying, yes, it can be done using technology, but which aspect of this rupture disks almost like a proof that it can be achieved. And one of the things we like to talk about it, 5 million cycles. So what does it actually mean? Well, the number one reason for rupture disks failures in the process is fatigue. So if you imagine the disk is the weakest point in all of the process, it's designed to be the weakest point. So in the case of runaway reactions, for example, or any other safety case, the disk opens first, relieves an overpressure before actual equipment that it's protecting ruptures or being damaged. And with a rupture disk failing prematurely because of fatigue, for example, as a lot of common rupture disks or standard rupture disks in the industry do, the process stops. Okay, fatigue failures does not really associate with an overpressure event. It's simply the disk getting fatigued by cycling, and it requires to be replaced. So the process stops. As we already touched on it, the ways to prevent it is to carry out maintenance, so a replacement of the rupture disks every so often, and cycles would depend upon the process conditions. So, but what if we think about it? What if we use technology to try to mitigate the fatigue, the process impact on fatigue of the rupture disks? And that's what 5 million cycles is. So what is it? It's a test that we carried out on HPX family of products, where we subjected it to 5 million cycles from full vacuum up to operating pressure of the disk, and also for 5 million cycles and bursted at the end. And the test demonstrated that the disk hasn't been experiencing any fatigue. So it burst in the same, given the same burst result as its test results. So let me put it to you in perspective. What 5 million cycles means? It's if you have 1 cycle a minute, so full cycle we're talking about, not just a slight spikes in pressure. You can, in ideal scenario, without any other impact of the process like corrosion, for example, the disk could potentially run for 10 years until it fatigues out. So consider this. So you have now a disk in a process that no matter how many cycles you subject your disk to can potentially run for years before it needs to be replaced to address the premature failures due to fatigue issues. And so coming back again to our impact of this primarily on both unscheduled and scheduled stoppages. Up to 100% operation ratio. Now, this is fairly unique to the market. When we often speak about rupture disk, what you will hear is that, and some of our products are the same, is where there is a burst pressure, typically expressed as a range. So it will have a mean and a tolerance associated with it. Then the manufacturer would say that maximum available working pressure or operating ratio up to which you can, that's a limit up to which you can operate a working pressure within your process without a detrimental impact on the rupture disk, is expressed as a percentages of the burst pressure. So the best ones we hear maybe 90, 95%, something like this. So it leaves us with a gray area, what we would call, of 5%. So what would happen if you keep exceeding? Because once you reach minimum burst pressure, the disk is there to actually open and relieve the overpressure. So if you go into this gray area, then what you will find, you will simply fatigue the disk out faster. Now, consider this. Okay, our processes are designed typically, and the pressure relief equipment is installed to match the original design of the process. But how many processes right now are running to the original specs, especially if you have a plant which is 10, 15, 20, even 50 years old? There's been a lot of modernization happening. There's been a lot of upgrades. So even on the surface of this, we cannot completely guarantee that everything runs as it's been originally designed. And if we take this into account and also add what we're trying to achieve here in the process, try to increase our productivity by running it longer or by increasing throughput, but trying to intensify the process. So that again in itself will often lead to spikes in the process. So the industrial controls will often get compromised. So it's becoming more difficult to control the process. And you will start experiencing, for example, often the crossovers into this gray area. And again, it will potentially lead to premature openings of rupture disks, so accelerated aging and fatigue. But if you have a technology that can that allow you potentially to operate the process and withstand the spikes with up until the actual burst pressure, that again gives us an opportunity to mitigate some of those issues in the process control without detriment to the process. So once it crosses into the burst pressure range, okay, then it means we have an overpressure event, this opens, great. But at the same time, if we're trying to intensify and play with our process and trying to make it to increase the throughput, this technology allows you to do it, because coming back to the issue, if the disk opens, remember, everything stops. No matter what great things we're trying to achieve, the process will stop and it start immediately costing us money straight away. So just to put this in perspective, what all of the things that you hear from rupture disk people that perhaps maybe sounding like industry jargon, or maybe often looked as maybe of meaningless, what doesn't mean for me. This is what it does actually, and that's how it impacts. And the last but not least, so I'm only going to concentrate on three major things that has a direct correlation, direct impact on actual productivity of the process. It's precision performance. While we're talking about this, that sounds a bit of a more than advertising statement. Well, no matter in a sense how it sounds, it's still quite important. So let's remember that safety, whatever we're trying to do with our process and with the technology that we have, is we must never compromise the safety of the process. Because once that compromised, that you all seen industrial accidents and the consequences of them. So, and if you look at two previous things of robustness of the design and the very tight tolerance, a very high maximum allowable working pressure ratio, that the actual tight performance, the plus minus 5% tolerance in the burst pressure, which is fairly tight, and there are quite actually very few processes that requires tighter than this. It still allows us to increase all the other things like maximum allowable working pressure ratio to bring it up and allow us to still operate process that a bit more intense without having a detrimental effect again on either safety or what we're trying to achieve as an operation. So because everything is related with each other, and if we can move the burst pressure closer to the design pressure of the process without compromising safety, then it allows us to do so much more within the process itself that we couldn't do before. So if you put all these things, three things in perspective, so the whole philosophy behind us developing the HPX technology is, okay, we can say there are so many variables within the process, and there are so many variables within metallurgy of in the materials that the rupture discs are made of. It's near to impossible to say exactly when the rupture disc would need to be replaced. But what if we trying to mitigate all of these factors and reduce the risks to the process from the operational efficiency point of view and optimization of it as much as possible to allow us to more protracted longevity and more a longer uninterruptible process. So, and all of this, in my opinion, these three main topics have a direct correlation with productivity. Also, just whilst we're talking about, the whole platform is very versatile as well. So that can be actually delivered to majority, I would say 90%, probably 95% of all processes of typical plant. So it covers both lower pressures, higher pressures. Something we haven't mentioned really in this discussion is, of course, another important factor of corrosion effect on the longevity of rupture disc. So that something is typically mitigated through alloys. So what kind of materials we're using to resist this corrosion. And the great thing about the HPX platform is that it can come in a variety of corrosion-resistant alloys. Anything from standard, what becoming standard 316 stainless steel, up to pure elements like tantalum, for example, for highly corrosive process like bromine process, for example. So that's something we would use to mitigate the effect of corrosion. Again, and it will have a direct correlation to the longevity of the rupture disc process. So, and of course, it also prevents, the whole platform is designed to prevent an incorrect installation, because coming back to the fact that the rupture disc must be installed properly in a correct way in order for them to perform their primary function, of course, to provide the safety. So whatever we do with our technology, of course, we have to remember always in safety. But so hopefully what we've covered during this kind of a short overview is there is a way of looking at what technological advances we as a manufacturers of equipment that's being used in the process can bring to the table right now in order to achieve something that previously was thought to be impossible. Yeah, rupture disc is there, it provides a safety and we have to live with it. So, and our processes are limited by the performance of our pressure safety equipment. And this is becoming, I wouldn't say no longer a case, but we are now have a unique chance to look at what additional opportunities we have now to optimize our processes. And with use of HPX technology and the impact it has on reliability of the rupture discs in the process significantly would outweigh the cost of ownership. Of course, what we can do, again, this is a theory behind supported what technology does, and this is not something that we have introduced in the past year. No, the technology itself been over 15 years on the market, was constantly improving the different aspect of the design, and we believe from mechanical standpoint, this is the best technology available on the market. But also, I think it's a good time for us now, because of where we are finding ourselves in the situation, to now look what this technology can do for our process beyond safety. And I hope it demonstrated to you that the impact has significant benefits to the process and to our impact on our financial performance than actually the cost of running it. So it's not just becoming a cost that we have to live with, but actually more transforming into opportunity. Now, something I would like to mention as well is that, okay, technology is one thing, it's great, but many of businesses that drive technological advances often fail in their business model is because they cannot get other things like customer service or customer support, more importantly, in place that would require customers to use the technology itself. So what we as a business are doing, not just spearheading the technological advances in our field, but also supporting operations of our customers. So on one hand, the product is reliable, it's great, but what would happen is if there is an overpressure event in the process, and all of a sudden, okay, the disc operated as intended, but we have now in need of replacement. And for one reason or another, let's say this replacement is not available in stock. Well, here we are, and that's where the importance of having a partner like CDC in place. We can provide, for example, a replacement discs with our Red Bull service within 24 hours. We manufacture all possible codes and standards that exist for the rupture disc currently in the market. And we always internally manufacture discs and test them, more importantly, beyond what just mere standards or legislative requirements are. So you can, one of the things, we're not inviting you to just play with technology and use your process as a testing bed. It's not about this. It's about using us as a partner with our technology in order to drive and do something better with your process, give you an opportunity to improve productivity and optimize your processes as well. So we also have engineering support and customer service support in all the continents of the world. And we're working together for example, like, and I would like again to thank you for organizing this event, is to support you on 24-hour basis. And also part of this thing, so we talked about what the technology can do, but how to do it is as well. So we're taking our customers through the process of looking at the current practices, looking at what maintenance schedules and plans are, what the training requirements are, and how to actually implement this technology in your process as the best and most efficient way, so you can start benefiting from it immediately. So all of this we're doing together with our partners. So if you would like to start this process, please get in touch, and we will go through a number of different things together in order to get you going, in a sense. And just to conclude again, the overview of what we did is, I hope you had, within the time permitted, a little insight of the roles of the rupture discs in a process. They do have significant impact on operational efficiencies. And it could be positive, like we discussed with HPX technology, and it could be a negative if other technologies are less reliable or less advanced and possibly used. And the impact, positive impact of HPX technology we've discussed delivers a permanent improvements to the process. We're not talking about this as a quick fix of some issues associated with pandemic. No, it doesn't matter what you plan to do in 10 years' time. It still will drive and support you in all your goals and aspirations. Again, this is a technology that can drive down the cost of ownership. And we're not talking just about cost of spares. That actually is the smallest cost there is in the process. But the actual cost of a loss of production, cost of maintenance, cost of product itself that being lost often once you have an open vent scenario. And of course, we are here with our partners to support you 24/7 and all around the world. And you need to ask yourself, can you afford not to use the latest and the best in technologies there is to actually drive and optimize your process? Okay, so thank you very much for listening, for your attention.